It started as an experiment to create an absorbent material for the next generation of diapers, but it turned out to be much more. Using byproducts from the lumber industry and pulverized crustacean shells, Joel Pollack and his team from North Carolina State University came up with a foam substance with absorbent properties beyond anything they expected.
So we started looking at how does the product work, or how does this material work at taking up saline or salt water. And through that process, we found out that not only does it take up a whole lot of salt water, it also takes a lot of the salt out of the water. So it is actually sort of a salt sucker.
And the implications are significant. In countries where fresh drinking water is in short supply, Pollack says his foam could one day be used to extract salt from seawater before final purification in a desalination plant, thereby increasing the plant's efficiency. Having demonstrated its salt extraction abilities, Pollack was curious about what else the foam could do.
So we took this material, and now that we knew that it could take up water, that it could remove salt from water, we're curious to see, could it remove heavy metals from water? And as what we were able to find out is that indeed it does remove heavy metals quite well from water.
In this experiment, researchers are dissolving large amounts of arsenic in water to simulate the contaminated water sometimes found in freshwater wells in India and Bangladesh. They measure the amount of arsenic in the water and then add a tea bag containing the foam. 5 minutes later, the amount of arsenic in the water has decreased by 70%.
We're using a material that has positive and negative charges that are right now attached together. When we put them into water, those positive and negative charges come apart and allow for salt, the positive and the negative ions of that salt, to attach to those charges inside the foam. We actually think that there's a possibility that when we put this in there and that opens up, we'll actually bind viruses, will bind bacteria into this material as well.
Pollack says that since his foam comprises byproducts of existing industries, it can be easily mass-produced to provide people contaminant-free water, and that includes water poisoned by radioactivity. After the recent nuclear crisis in Japan, Pollack and his team tested the foam's ability to remove radioactive material from water, and once again it performed well. The next generation of diapers, says Pollack, won't know what hit them. Ben Gruber, Reuters.